We are going to get started with our section 7.4 notes right now. Before we get going though, take a minute to put the properties from pages 462 and 451 on a note card. They're going to be helpful as we work through this section. Section 7.4 is properties of logarithms. I can use the properties of logarithms. Big ideas here are logarithms and exponents have corresponding properties. Remember that logarithms are exponents. It's just another way to write it to use with big numbers, small numbers, things that aren't real easy to use or to find. When we need to find a value in an exponent, we have to use logarithms. An exponential function is a function with the general form y equals a times b to the x power. In an exponential function, the base b is a constant. The exponent x is the independent variable with domain the set of all real numbers. So that's for our exponential function, y equals some number a times b to the x power. This take note on page 462 is properties of logarithms. This is one of the things I wanted you to write down. The product property is very comparable to the product property of multiplying powers with the same base. And I have these three up in the back corner of my room next to the happy face parabola as multiplying powers with the same base, dividing powers with the same base, and power to a power. Very, very similar here because logarithms are exponents. So with the properties of logarithms here, with the product property, when we multiply m times n in our logarithm, we can split that into two different pieces as log base b of m plus log base b of n. And that's when we multiply there. Okay, multiplying powers with the same base, we add the exponents. That's our corresponding exponential property. Quotient property here, if we have m divided by n, we subtract log base b of m minus log base b of n. So log base b of a quotient means we're going to take our same log base b, we keep this exactly the same for both pieces as in our original, just like we did with our product property, but we split up our quotient into subtraction. Just like when we're dividing powers with the same base, we subtract our exponents. Remember, logarithms are exponents. Power property here says that we can take our exponent and swing it out to the front as multiplication. So power to a power means we multiply our exponents. So we take our exponent times an exponent. Remember, logarithms are exponents. Okay. Example 1 here is simplifying logarithms. What is each expression written as a single logarithm? So, for example, a here in 1, the first thing that we're going to do is rewrite it as one piece. And we have subtraction. So we can rewrite that as log base 4. We keep those exactly the same. And we take our two values here. Since we have subtraction, we're going to divide those to put them together into 1 using that quotient property. Simplify that. We get log base 4 of 16. We're not done though. We never want to have any value here that can be simplified using exponents. So if we rewrite that, it's log base 4, 16 equals 4 squared. So instead of writing 16, I'm going to write 4 squared. The nice thing about that is if we use our product property there, we can swing that 2 to the front. 2 times log base 4 of 4. And we talked about this last week some, but log base b of b always equals 1. So log base 4 of 4 is just 1. We have 2 times 1, which is 2, which means this whole thing up here just equals 2. If you don't believe me, here in a little bit, I'll teach you how to type it in your calculator and you can check. Part B here, sorry about that. Same idea, we're just going to have to do our exponents first. So we're going to take those numbers in front, our coefficients, and swing them to the back as exponents using that product property. So log base 2 of x to the 6th power plus log base 2 of y to the 5th power. Before we can put these together, you guys, we have to have just our log base, whatever it happens to be. Before we can combine them into one, it has to be log base 2, log base 4, log base whatever you have, can't have any coefficients. Now, since our logs have the same base here, I can take log base 2, and I'm going to take these two pieces here using my product property, and I'm going to multiply them, x to the 6th times y to the 5th. I put parentheses there to show that it's log base 2 of this whole quantity, of that whole value. And that's all the further I can go there. Now let's try some. You can go ahead and pause here if you want. Try these. I'm going to start working them out. So here we have logarithms with the same base, log base 4. So what I'm going to do is I'm going to combine those into one. We want it as a single logarithm. So log base 4, we're adding, so that means I'm going to take these values here and multiply them. 5x times 3x. Simplify within our parentheses here. Log base 4 of 5 times 3 is 15. X times x is x squared. And we're going to leave it just like that. Some of you might be wondering why I didn't take and swing this 2 to the front. And that's because it's not the exponent on the 15. So we can't swing it to the front using that product property because it's not an exponent for the whole thing. It's just for the x. So be very careful there. Second one here. Again, before we can combine these into one, we have got to have it so it's just log base 4. We can't have any coefficients anymore. They have to be the exact same base. So I'm going to go here with log base 4 of 6 squared minus log base 4 of 9. We know what 6 squared is. Log base 4 of 6 squared is 36 minus log base 4 of 9. Since we're subtracting, I'm going to take my values with my same logarithm, log base 4, and I'm going to divide them. Take 36 divided by 9. As always, we simplify when we can. We get log base 4. 36 divided by 9 is 4. And according to our property, log base b of b is always just 1. So here it equals 1.